It's your friendly math tutor, Miss C here, and today we are rationalizing the denominator when the denominator has a binomial. So, as a reminder, when we rationalize the denominator, we're essentially removing any radical or any root bar from the denominator. That's what rationalizing the denominator means. So, in my last video, which I'll link below, we simplified or we rationalized the denominator when we had a monomial or a single root in the denominator. Today, we are going to be rationalizing the denominator when we have something that looks like this, where there is a binomial or a two-term denominator, and at least one of the terms, if not both, contains a radical. So let's get started. So we have new vocabulary to introduce here because we have to find conjugate pairs in order to rationalize the denominator when a binomial is present. So basically, a conjugate pair is a set of binomials that are the same, so the same numbers, same radicals, except they have the opposite sign in between them. So, for example, if I have 1 plus root 13, its conjugate pair, so its pair would be 1 minus root 13. Okay, that's it. So that's the conjugate pair. If I have 4 minus root 5, the conjugate pair would be 4 plus root 5. Okay, not too bad. But this is how we get the roots out of the denominator when we have a binomial. So let's look at our first problem. We have 7 divided by 1 plus the square root of 13. We need to first identify that this is a binomial and requires the use of a conjugate pair. That means I'm going to multiply this by 1 minus root 13. So I'm multiplying it by its conjugate pair. What I do to the denominator, I do to the numerator because I'm creating a fraction that looks different but has the same value. So an equal fraction. All right, when I do that, I'm going to go ahead and leave the numerator as 7 times 1 minus root 13. And in the denominator, I'm going to FOIL this over here for us, and then you'll see the pattern. So we end up with 1 times 1, which is 1. We end up with 1 times negative root 13, which is negative root 13. We end up with positive root 13 times positive 1, so that's positive root 13. And then we end up with root 13 times negative root 13, which is the square root of the negative square root of 169. Okay. So, what always happens when you multiply a binomial by its conjugate is this, and there's a root bar, is this middle number always cancels out. Okay. This is like the difference of squares if you've done that before. So what ends up happening is we end up with 1 minus, well, we know that we just multiplied root 13 by root 13 to get root 169. We know that when we take the square root of 169, we're going to get 13. So what ends up happening is we end up getting 1 minus whatever the square root of our perfect square is, and that is the pattern that always happens. So in this case, it's negative 12. Okay, so we're going to go ahead and now simplify the numerator. So we end up, I'm going to distribute 7. 7 times 1 is 7, minus 7 times root 13 is 7 root 13, all divided by negative 12. You could leave your answer like this. All right, let's look at our next problem. So here we have 12 divided by quite the binomial, 3 times root 5 minus root 2. So we're going to start this the same way we did our last problem. We are going to multiply this by its conjugate pair. Since this is subtraction, we are going to add root 2. And what I do to the denominator, I do to the numerator to make sure that I'm not changing the value of my fraction. Okay, we have lots of options here. I'm going to go ahead and in this example, because I don't like writing things over and over, I'm going to go ahead and distribute the 12 before I rewrite this. So I end up with 12 times 3, which is 36, and that's multiplied by root 5, plus 12 times root 2. So that's my numerator. The denominator is going to be a little more challenging because we've got roots all around. So I'm going to go ahead and I'm going to write it over here for us to FOIL out. And then we'll put it in the fraction. So here we go. We have 3 root 5 times 3 root 5. Remember, when you multiply this, the 3's get multiplied together. So that's 9. And then the roots get multiplied together. So root 5 times root 5 is root 25. And then we have root 3 times root 2. So that's plus 3. Then our roots get multiplied, which is root 10. I know because I have a conjugate that these two multiplied together are going to be the exact opposite. That's how conjugate pairs work. So I know that that's going to equal negative 3 times root 10. And then finally, negative root 2 times positive root 2 is negative root 4. So as in our last example, this middle term, the middle terms equal 0. They cancel each other out. But now I have 9 times 5, right? Because root 25 is 5. And then I have minus root 4, which is 2. So this gives me 45 minus 2, which is 43. And the good news is that's as simple as it gets. So this is our final answer. All right, last one is a little simpler than the last one with respect to the denominator. The numerator is a little more complex, but we will deal with that. So my first step is this is a binomial root, or binomial that has a root in it in the denominator, so we multiply by the conjugate pair. If I do that to the denominator, I have to do it to the denominator. If I do it to the denominator, I have to do it to the numerator as well. But here's what I need to be careful about. This is a common error I've seen. You need to put parentheses around this binomial first because it's not just being multiplied by root 3. It's being multiplied by the whole numerator. Okay, so we've got some foiling to do on both fronts. So I'm going to change my color here and do the numerator in yellow. So I'm going to go ahead and start foiling my numerator. 6 times 4 is 24. 6 times root 3 is plus 6 root 3. Root 3 times 4 is 4 root 3. And root 3 times root 3, I'm just going to write this out as root 9. We'll simplify that later. In the denominator, we have 4 times 4, which is 16. We have 4 times root 3, which is 4 root 3. We know what's going to happen next, right? Because this is a conjugate pair. We end up with 4 times negative root 3 when we FOIL those two. And then we have negative root 3 times positive root 3, which gives us negative root 9. Now, it is very tempting to just start canceling things out right away. But stop, you can't do that because there's so many addition signs in the denominator, addition and subtraction. So you cannot cancel things out when there's addition or subtraction signs in the denominator like you would if it was being multiplied. So nothing to cancel out here. What we need to do is come up here and we need to simplify. So let's go ahead and do that. I'm going to say that this is 3, right? So we know that root 9 is 3. So I'm going to have 24 plus 3. Those are like terms. So I end up with 27. And then I have 6 root 3 plus 4 root 3. Those are also like terms because they have the same root. So I can add those together and I get plus 10 root 3 divided by. All right. I'm noticing my conjugate pair, this goes away. That makes a big old 0. And then this I know equals 3. So I have 16 minus 3, which is 13. Okay, there is nothing to simplify. And if this was like, say, well, there's nothing that would simplify in both of these because 27 is odd and 10 is even. But if this was a number in the denominator that could go into both of these terms, you have to divide both of those terms if you're going to simplify. So maybe I need to make another video about that so you simplify correctly because it's a really easy mistake to make. All right, so that is our simplified answer. You just worked through 3 pretty challenging problems. Give yourself a high five. Make sure to subscribe for more videos. Till next time, remember, you've got this.